Hi everyone, let's continue the review for test 3. By this question, find a polynomial function with the zeros -3 with multiplicity 2 and positive 3 with multiplicity again 2, whose graph passes through the point -4 and 147. Because one of the zero for this function, it's -3, it means that there is factor x minus -3 in the function, and because there is another zero positive 3, so we have factor x minus positive 3. So this factor is x plus 3 and this factor is x minus 3. Then we know that the multiplicity of -3 is 2, so it means that there are two factors x plus 3 in the function, or x plus 3 has exponent 2. Also, multiplicity of positive 3 is positive 2, so there are two factors of x minus 3 in the function. So actually the function is a square of x plus 3 and a square of x minus 3. What else? Because it passed through the point -4 and 147, if this is the x value, f of -4 is 147. Also, there is a coefficient here. I don't know what is that coefficient, so let's call it just a. And then we know f of -4, it's 147. F of -4, it's 147. Also, f of -4, based on the equation of the function, this equation, when we plug -4 in the function, is a times the square of -4 plus 3 times the square of -4 minus 3. So f of -4, it's equals to a times the square of -1 times the square of -7. So f of -4, it's equals to a square of -1 is 1 and a square of -7 is 49. So it's 49 times a. We know that f of -4, it's 147. So here it's equals to 147. 147, it's 49 times a. So we can conclude that a is 147 divided by 49, which is 3. Now we can write the equation. The equation is a, which is 3, times the square of x plus 3 times the square of x minus 3. The next question, we have a function f of x, which is x minus 8 to the power 3 times the square of x plus 3. We are looking for all real zeros and their multiplicity, and we want to see at these zeros or these x-intercepts, the graph of function touches the x-axis or pass through the x-axis. And what is the power function that the graph of f resembles for large value of x? So look at the function. The function is power 3 of x minus 8 times power 2 of x plus 3. When we are looking for zeros of the function, it means that f of x should be 0. So multiplicity of a and when we multiply a and b, the answer is 0. It means maybe a is 0 or b is 0. So if x minus 8 to power 3 is 0, it means x minus 8 is 0. And we can conclude that x is positive 8. What is the multiplicity of this 0 for the function f? The multiplicity is 3. Also, we have x plus 3 squared that can be 0. If a square of x plus 3 is 0, it means that x plus 3 is 0 and x is negative 3. This is another 0 for the function. What is the multiplicity of negative 3? Is 2. So zeros of the function are positive 8 and negative 3. Positive 8 with multiplicity 3 and negative 3 with multiplicity 2. Okay, because the multiplicity of 8 is 3 and 3 is odd number, we know that at this specific x-intercept, x equals positive 8, the graph of function passes through and crosses the x-axis. So at 8, function crosses the x-axis. And as we know, the multiplicity of negative 3 is 2, and 2 is an even number. We can conclude that the graph of function at negative 3, at x equals negative 3, touches the x-axis. What is the power function that the graph of this function f, resembles for large value of x when x goes to positive infinity or negative infinity? From this term, which is x minus 8 to power 3, we just look at x to power 3. And from this one, x plus 3 to power 2, we just look at x to power 2. So the power function that the graph of f resembles for a large value of x, from here is x to power 3, and from the next term is x to power 2. So overall, it's x to power 2 plus 3, which is 5. So the power function is x to power 5. Next question. In the next question, we want to use remainder theorem to find the remainder when f of x is divided by x minus 1. This is f of x. I want to know what is the remainder when I divide f of x by x minus 1. So instead of doing the long division and then see what is the remainder theorem says that when you are looking for a remainder of function when is divided by x minus c, look at f of c. F of c is the remainder when f is divided by x minus c. In this case, we have x minus 1. So c here is positive 1. So let's see what is f of 1. F of 1 means we need to plug 1 in the function. So instead of x, we substitute 1. We have 2 times 1 to power 4 minus 5 times 1 to power 3 plus 9 times 1 minus 6. Let's calculate. It's 2 minus 5 plus 9 minus 6. 2 minus 5 is negative 3. Negative 3 plus 9 is positive 6. Positive 6 minus 6 is 0. Okay, we divided f of x, which is 2x squared minus 5x to power 3 plus 9x minus 6 by x minus 1, and then we found that the remainder is 0. It means x minus 1 is a factor for this function. So the remainder is 0. And by factor theorem, right now we know that x minus 1 is a factor for this function. Let's work on the next problem. Here we have a function, and we want to know what's the maximum number of zeros that this polynomial function may have. The number of 0, the maximum number of 0, or it's better to say the maximum possible number of 0 for a polynomial, it's equals to degree of the polynomial. What is the degree of this polynomial? Degree of this polynomial, it's the most exponent of the variable. The most exponent is 10. So the maximum number of zeros for this polynomial is 10. Does it mean that there are 10 zeros for this polynomial? 10 real zero? No. Remember the quadratic function with degree 2? Although the degree is 2, sometimes it has 2 real zeros, sometimes there is just 1 real 0, and sometimes there isn't any real 0. So similar to that. Then how many of this real 0 can be positive, or how many of them are negative? By Descartes' rule, to check how many of them are positive, we look at the function f, which is negative 7 x to power 10, negative 9 x to power 8 minus 2x plus 5. We count the number of changes in sign of the coefficient of x. For example, between negative 7 and negative 9, both of them are negative, so there isn't any change in the sign. Then from negative 9 to negative 2, again, there is no change. Between negative 2 and positive 5, one of them is negative, the other one is positive, so there is one change. It means there is one real positive 0 for this function by Descartes' rule. How many negative real 0 can the function have? Again, by the Descartes' rule, first of all, we calculate f of negative x. This is f of x, so instead of x, I plug negative x. It becomes negative 7 times negative x to power 10 minus 9 times negative x to power 8 minus 2 times negative x plus 5. Let's rewrite it. Negative x to power 10 becomes just x to power 10 because negative 1 to power even is positive 1. And negative 1 to power odd is negative 1. So f of negative x, it's negative 7x to power 10 minus 9x to power 8 plus 2x plus 5. Now let's count the number of changes in the sign of the coefficient of x. Negative 7 to negative 9, no change. Negative 9 to positive 2, 1 change. Positive 2 to positive 5, no change. There is only 1 change. So by Descartes' rule, there is only one negative real zero for this function. So as you see, this function has 2 real zeros. One of them is positive and the other one is negative. You may think that, but we think that there are 10 zeros for this function. Then how about the rest of them? Rest of them are complex zeros. In the next problem, we want to use rational zero theorem to list the potential rational zeros for this polynomial. What was the rational zero theorem? The rational zero theorem says that if you have function f of x, which is a n x to power n, a n minus 1 x to power n minus 1, a1 x plus a0, when a0 it's non-zero and an also is non-zero, then if you find the factors of a0, and let's call the factors for a0 p, and then find the factors of an and let's call them q, then p divided by q is the set and the list for potential rational zeros for this polynomial. Now, look at the function. What is the degree of this polynomial? The coefficient, the leading coefficient of the function is an. Degree of this polynomial is 9. And an in this case is negative 4. This is an. A0 is the constant and it is positive 2 in this case. So an is negative 4. What are the factors for an? Let's call the set q. The factors is positive and negative 1, positive and negative 2, and positive negative 4. A0 or the constant is positive 2. What are the factors for positive 2? It's positive negative 1, positive negative 2. Then what is the list of potential rational zero when we divide, this is p, when we divide p by q? So we divide positive and negative 1 by each member of q, by positive and negative 1, positive and negative 2, positive and negative 4. And the next term in P is positive negative 2. We divided by positive negative 1 by positive negative 2. And we divided by positive negative 4. Now, this is positive negative 1, positive negative 1/2, positive negative 1/4, positive negative 2, again positive negative 1, so we don't need to include it because it's just positive negative 1, and again positive negative 1/2, which we have it here, so we don't need this. These two are extra. So positive negative 1, positive negative 1/2, positive negative 1/4. So you see that D cannot be the answer because it doesn't have positive negative 1/2, 1/4. And then positive negative 2. Positive negative 2 are here and here. So which one is the answer? This one. Why? Because here we have positive negative 4, but here we don't have positive negative 4. So the right choice is C. The next question, we want to use intermediate value theorem to show that this polynomial has a 0 in this interval, negative 2 and 0. What is the intermediate value theorem? What says this theorem? The intermediate value theorem says that if you have a function f of x in the interval between a and b, and f of a times f of b is negative, it means one of them is positive, the other one is negative, then the function f has at least one 0 between a and b. So our job is to check what is f of endpoints, negative 2 and 0. f of negative 2 is 10 times negative 2 to the power 4 minus 2 times negative 2 squared plus 7 times negative 2 minus 1. So what is the answer? Is positive or negative? Negative 2 to the power 4, it's positive 16 times 10, it's 160. Negative 2 to the power 2 is positive 4. Times negative 2, it's negative 8. Negative 2 times 7, it's negative 14 minus 1. What is the answer here? Definitely is positive. You can calculate it. What is f of 0? It's 10 times 0 to the power 4 minus 2 times the square of 0 plus 7 times 0 minus 1. What is the answer? Is negative 1. As you see, it's less than 0. It's negative. And based on intermediate value theorem, there is at least one real 0 between negative 2 and 0. And so the answer is yes. The next problem, we have a polynomial, and these are information about the polynomial. We know the degree is 3, and the zeros for this polynomial is negative 3 and negative 3 minus I. We are looking for the next 0 for this polynomial because it is degree 3. It should have it should has 3 zeros. Right now we have just 2 of them. Between these two, one of them is complex 0. We know that if a complex number is a 0 for the function, conjugate of that complex number should be another 0 for the function. What is conjugate? If a plus ib is a complex number, then conjugate of a plus ib, that I showed by a plus ib bar, is a minus ib. So what is the complex of -3 minus I? It's -3 plus I. So -3 plus I is the remaining 0 for this function. If you want to write the function just based of this information, because -3 is 0 for the function, you know that x minus -3 is a factor for the function. Because -3 minus I is another 0, x minus -3 minus I is another factor. Also, we know that -3 plus I is another 0 for the function, so x minus -3 plus I is another factor. And maybe there is a coefficient here. So if you want, you can multiply and find the polynomial for this function. In the next problem, we are looking for vertical, horizontal, and oblique asymptote for this function. You see that we have a rational function. To find the vertical asymptote, we know that vertical asymptote are zeros of denominator. So what are zeros of denominator? It means that x squared minus 2x minus 8, you need to set it to 0 and solve this equation. We can factor this equation to x minus 4 times x plus 2, because -4 times 2 is -8, and -4 plus 2, it's -2. So the x minus 4 can be 0, and x is 4. X plus 2 can be 0, and x is -2. These two numbers are vertical asymptote for the function. So x equals 4 and x equals -2 are vertical asymptote for the function. How about the horizontal asymptote? Degree of numerator is 3 and degree of denominator is 2. Degree of numerator is 3, degree of denominator is 2. It means that degree of numerator is greater than denominator, and in this case there isn't any horizontal asymptote. But when you divide numerator by denominator by doing the long division, you can find the oblique asymptote. So let's calculate the oblique asymptote. X to power 3 minus 64 divide by x squared minus 2x minus 8. X to power 3 times x squared is x. Now you multiply x by each term of the quotient. So you have x to power 3 minus 2x squared minus 8. Do the subtraction. The remaining is positive 2x squared, negative 64 plus 8 is negative 56. Now you divide 2x squared by x squared, becomes 2, multiply 2 by each term here. 2 times x squared, 2 times negative x, 2 times negative 8. And do the subtraction. The remaining is positive 4x and negative 56 plus 16 is negative 40. And I cannot continue. Why? Because we cannot divide 4x by x squared. So this is the remainder part, and this is the oblique asymptote. Y equals x plus 2 is the oblique asymptote for this function.